Hello, in this lecture we will find the radius of the semicircle. In the drawing we have triangle ABC. Triangle ABC is a right triangle because angle ABC, this angle is a right angle, and inside triangle ABC we have this semicircle. Actually, side AB of triangle ABC is tangent to the semicircle at point B, and side AE or line segment AE is tangent to the semicircle at point E. Point E is the touching point between tangent AE and the semicircle. And we also know that side AB equals to 3 units in its size. Line segment CD equals to 1 unit in its size, and we want to find out the size and the radius of this semicircle. Okay, so first of all I will present to you a new rule, rule number 1. According to rule number 1, or we can also call it two tangents theorem, the lengths of two tangents, the lengths of two tangents from a common external point to a circle are equal. I will read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and from this point, point P, we will draw two tangents to this circle. Actually, point P is an external point in relation to this circle because of the fact that point P is not located inside this circle nor on this circle, but it is located outside this black circle, therefore point P is defined as an external point to this black circle. So if from point P we will draw two tangents to this circle, then the length of those two tangents will be equal to each other. So the first tangent is this is the first tangent. We will define the touching point between the circle and the first tangent as point A. And actually the length of this tangent is PA. So we will draw also a second tangent to this circle from point P, from the external point P. And we will define the touching point between the second tangent and the black circle as point B. And actually the length of the second tangent is actually PB. PB is the length of the second tangent. And according to rule number 1, whenever you draw two tangents from an external point to a circle, then the length of those two tangents will be equal to each other. The length of the first tangent is PA, the length of the second tangent is PB, and according to rule number 1, the lengths are equal to each other, that is to say PA equals to PB. Again, whenever you draw from an external point, in this case is point P, two tangents to a circle, then the length of those two tangents, will be equal to each other, that is to say PA equals to PB. Okay? PA equals to PB. Okay, so actually we can implement rule number 1 or two tangents theorem. This is the two tangents theorem, so we can implement this theorem in our drawing, because in our drawing we have point A. Actually point A, that is the vertex of triangle ABC, is an external point in relation to the semicircle. So from point A, this point, we have two tangents to the semicircle. The first tangent is AB, and the touching point between this tangent to the circle is at point B, and the second tangent to the semicircle is the second tangent, tangent AE, and the touching point between the second tangent to the semicircle is at point E. So actually the length of the first tangent is AB, and we also know that AB equals to 3 units. And the length of the second tangent to the semicircle is AE. And according to rule number 1, or according to two tangents theorem, whenever you draw from an external point two tangents to a circle, then the length of those two tangents will be equal to each other. That is to say, AB will be equal to AE according to rule number 1. AB equals to AE. AB equals to AE. But we know that AB equals to 3 units. It is given us in the question. So AB equals to 3 units. So from this equality, we can 3 equals to AB equals to AE. We can derive that AE also equals to 3 units. Okay, AE also equals to 3 units. So we write here that AE, line segment AE equals to 3 units. So in the next step, I will present to you a new rule. First of all, we will define the center of this semicircle as point O, and actually OB or BO, line segment BO, is the radius of this semicircle because of the fact that line segment OB starts from the center of the semicircle, that is to say from point O, and ends at point B, that is a point on the semicircle itself. Therefore, OB is the radius of this semicircle, so we will define the radius of the semicircle as R, small r, so OB equals to R. And from the same reason, also OD will be also equal to the radius of this semicircle, so we will define OD as R. It is the radius of this semicircle. Then we will join points O and E together by a straight line. Actually, line segment OE is also the radius of this semicircle because of the fact that line segment OE starts from point O, that is the center of the semicircle, and ends at point E, that is a point on the semicircle itself. Therefore, OE is the radius of this semicircle, so we will define it as R. So now I will present to you a new rule, or rule number 2. According to rule number 2, or rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 2 again. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and suppose that the center of this circle is at this point O, and we also have tangent AB to this black circle, I will repeat again, tangent AB in the red line is tangent to the black circle. At this point, we'll define the touching point between tangent AB and the black circle as point M. M is also defined as the point of tangency, the point of tangency of tangent AB with the black circle. And we will draw radius of this black circle from the center of the circle, and actually the radius this radius is drawn, we'll define it as R. This radius is drawn to the point of tangency, that is to say, it is drawn to point O, to point M, that is the point of tangency. Therefore, according to rule number 2, the tangent AB will be perpendicular to this radius that is drawn to the point of tangency. That is to say, this radius is drawn to point M, that is the point of tangency. Therefore, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, or angle OMB will be equal to 90 degrees, and this angle OMA will be also equal to 90 degrees. So I'll repeat again. Whenever you have a radius, like in this drawing, that is drawn to the point of tangency, that is to say, this radius is drawn to point M, that is the point of tangency of tangent AB with the black circle, then, according to rule number 2, this tangent AB will be perpendicular to this radius. That is to say, this angle OMB will be equal to 90 degrees, and this angle also, angle OMA, will be also equal to 90 degrees. Okay, I'll repeat again. Whenever you have a radius that is drawn to the point of tangency of the tangent, then that tangent will be perpendicular to the radius. In this case, this radius OM is drawn to the point of tangency point M. Therefore, the tangent AB is perpendicular to this radius. This is to say this angle is 90 degrees and this angle is also 90 degrees. Okay? And again, we can also implement rule number 2 in our drawing, because in our drawing, point A is the point of tangency of tangent AC with the semicircle. So point E is point of tangency, and actually the radius OE is drawn to the point of tangency, that is to say it is drawn to point E. Therefore, the tangent AC will be perpendicular to this radius that is drawn to the point of tangency. That is to say, this angle will be equal to 90 degrees. And this angle OEC, will be also equal to 90 degrees. It will be a right angle. So, according to the rule that whenever you have a radius that is drawn to the point of tangency, then the tangent will be perpendicular to the radius. That is to say, this radius OE, is drawn to the point of tangency, that is to say it is drawn to point E. Therefore, the tangent AC will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so because of the fact that angle OEC is a right angle, therefore triangle OEC will be a right triangle. So we will focus on the right triangle OEC. Actually, I will paint it in the green color. We will focus on this right triangle OEC. So on the right triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. I will repeat again, according to the Pythagoras theorem, in the green right triangle OEC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on the right triangle OEC is OC. So the square of the hypotenuse, it is actually OC square equals to the sum of the squares of the perpendiculars equals to OE square, that is the first perpendicular, plus EC square. EC square is the second perpendicular of triangle, the right triangle, triangle OEC. So here we will define side EC of triangle EOC as x, that is to say EC equals to x units in its size. So in total we got that according to the Pythagoras theorem, in the right triangle, triangle OEC, OC square equals to OE square plus EC square. But what is the size of OC? The size of OC, from the drawing, we can see that the size of OC, it is actually OD plus DC. Okay, OC equals to OD plus DC. OD is the radius of this semicircle and DC equals to 1. It is given us in the question that DC equals to 1 unit. So in total OC will be equal to R plus 1. So OC square will be equal to R plus 1 square. And OC square equals to OE square. What is the value of OE? OE equals to R. We have already found out that OE equals to R, so OE square will be equal to R square plus EC square. EC square equals to X, according to our EC equals to X, according to our definition. So EC square will be equal to X square. So in total we got that according to equation number 1, R plus 1 square equals to R square plus X square. Here we will open the brackets on this side of equation number 1 and we will get that R plus 1 square is R square plus 1 plus 2R according to the identity that A plus B square equals to A square plus B square plus 2 times AB, and all equals to R plus X square. Okay, it equals to R square plus X square. Okay, so here we have R square in this side of equation number 1 and we have R square on the other side of equation number 1. So we subtract R square from equation number 1, so R square will get cancelled. And what is left after we cancelled R square? What is left? It is actually 1 plus 2R equals to X square. So we found out that according to equation number 1, 1 plus 2R equals to X square. So in the next step we will focus on the right triangle, triangle ABC, the right big triangle, triangle ABC, and we will also focus on the small green triangle, small green right triangle, triangle OEC. Okay. I'll write it down. So we'll focus on triangle ABC, the right big triangle, triangle ABC, and the right main triangle, small triangle, triangle OEC. Actually, this angle ABC of the big triangle ABC equals to 90 degrees. So angle ABC of triangle ABC equals to angle OEC, this angle. It is also a right angle. So angle ABC equals to angle OEC. And both angles are equal to 90 degrees. So those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle ABC equals to angle OEC, and both angles are equal to 90 degrees. Okay, and we have also this angle ACB. Actually, this angle is a common angle because of the fact that this angle belongs to both triangles. It belongs to the big triangle, triangle ABC, and this angle also belongs to the small triangle, triangle OEC. So we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. It is a common angle that belongs to both the triangle ABC, and also it belongs to triangle OEC. So it is a common angle. So angle C equals to angle C. And also those two angles are also equal to each other, and I will prove that those two angles are equal to each other. So angle BAC of triangle ABC this angle BAC of triangle ABC is equal to angle EOC of the great angle, this angle, and those two angles are equal to each other according to third angle theorem. So they are equal to each other according to third angle theorem. I will repeat again. Angle BAC equals to angle EOC according to third angle theorem. So what is a third angle theorem? Third angle theorem states that according to third angle theorem, if two angles of one triangle are equal to two angles of another triangle, then the third pair of angles must be also equal. The third pair of angles must be also equal. So I read the third angle theorem, or we can also define it as rule number 3. So according to rule number 3 of the third angle theorem, if two angles of one triangle are equal to two angles of another triangle, then the third pair of angles must be also equal. So what is the meaning of rule number 3 or the third angle theorem? The meaning of the third angle theorem is that if you have two triangles triangle ABC so this is triangle ABC. Know that this angle equals to alpha, this angle equals to beta, and this angle equals to gamma, and we have a second triangle, triangle CDE, so this triangle is triangle CDE. So this angle also equals to alpha, this angle also equals to beta, and this angle equals to theta. And according to the third angle theorem, angle gamma equals to angle theta. So the third angle theorem claims that angle gamma in triangle ABC is equal to angle theta in triangle CDE. We will prove that those two angles are equal to each other. First of all, you should remember that the sum of the angles in any triangle is equal to 180 degrees. So the sum of the angles in triangle ABC equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees, according to the rule that the sum of the angles in any triangle equals to 180 degrees. Likewise, in triangle DCE, also the sum of the angles equals to 180 degrees, that is to say alpha plus beta plus theta equals also to 180 degrees. Okay, so what is the value of angle gamma according to equation number 1? Actually, we will subtract alpha from equation number 1, and we will get that beta plus gamma equals to 180 degrees minus alpha. Then, okay, according to equation number 1, beta plus gamma equals to 180 degrees minus alpha. Then we'll subtract gamma from equation number 1, and we will get that angle gamma equals to 180 degrees minus alpha minus gamma. So we repeat on the same process on equation number 2. We'll subtract from equation number 2 alpha, and we will get that theta plus beta according to equation number 2 equals to 180 degrees minus alpha. We subtract from equation number 2 beta, and we will get that angle theta equals to 180 degrees minus alpha minus beta. Here in equation number 1, we subtracted alpha from equation number 1 and we got that beta plus gamma equals to 180 degrees minus alpha. Then we subtracted beta from equation number 1 and we got that angle gamma equals to 180 degrees minus alpha minus beta. Okay, because we subtracted beta from equation number 1, so we got that angle gamma equals to 180 degrees minus alpha minus beta. So actually we found out that the value of angle gamma according to equation number 1 is 180 degrees minus alpha minus beta. And we found out that the value of angle theta according to equation number 2, it is actually 180 degrees minus alpha minus beta. So we actually found out that both those two angles, angle gamma and angle theta, equals to 180 degrees minus alpha minus beta. Angle gamma equals to 180 degrees minus alpha minus beta, and angle theta also equals to 180 degrees minus alpha minus beta. Okay, so from this equality we will conclude that angle gamma equals to angle theta. So we actually proved that if we have two triangles and two angles of one triangle are equals to two angles of another triangle, then the first pair of angles must be also equal to each other, that is to say gamma equals to theta. Okay, so in this way we actually proved the third angle theorem. So we actually proved that three angles of triangle ABC are equal we proved that three angles 1, 2, 3 of triangle ABC are equal to three angles of triangle OEC 1, 2, 3. Therefore, we proved the triangle ABC is similar to triangle OEC according to angle similarity rule. So I'll write it down. We actually proved that triangle ABC is similar to triangle OEC according to angle similarity rule. I repeat again. We proved the triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Actually, angle similarity rule is that if you prove that three angles of one triangle are correspondingly equal to three angles of another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to triangle OEC, the green triangle, we will derive the following equality. We will conclude that side AB of triangle ABC over side AC of triangle ABC equals to side OE of the green triangle OEC over side OC of the green triangle OEC. I will repeat again. from the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC equals to OE over OC. Okay? But what is the value of AB? The value of AB from the drawing, you can see that AB equals to 3 units. It is given us the question that AB equals to 3 units. So AB equals to 3 units. What is the value of AC? The value of AC equals to 3 plus X. AC equals to 3 plus X. And all equals to OE. What is the value of OE? OE equals to R over OC. OC equals to R plus 1. So in total we got that three over 3 plus X equals to R over R plus 1. Here we will cross multiply equation number 2, and we will get that 3 times R plus 1 equals to R times 3 plus X. So we got this equality according to equation number 2. Here we will open the brackets in equation number 2, and we will get that three times R plus 3 equals to 3 times R plus Rx. Here we have 3R in this side of equation number 2, and we have 3R. We have 3R on this side of equation number 2, and we have 3R on the other side of equation number 2. So 3R will get cancelled. So what is left after we cancel 3R? What is left is it is actually 3 equals to Rx. 3 equals to Rx. We will divide equation number 2 by X, and we will get that R equals to 3 over X. Before that, why it is allowable to divide equation number 2 by X? Maybe X is 0. If X is 0, then you cannot divide equation number 2 by X, because you cannot divide any equation by X if X is 0. But as you can see from the drawing, X is side EC of the green triangle, triangle OEC. Therefore, it must be a positive number. As a side of a triangle must be a positive number. Therefore, it is allowable to divide equation number 2 by X, because X can never be 0, because a side of a triangle can never be 0. Okay, it must be a positive number. So we actually found out that the radius of the semicircle equals to 3 over X, according to equation number 2. But according to equation number 1, we have already found out according to equation number 1 that we have already found out that 1 plus 2r equals to x squared. 1 plus 2r equals to x squared. So we'll substitute r in equation number 1 by 3 over x from equation number 2, because r equals to 3 over x. So we can substitute r in equation number 1 by 3 over x. So we'll do it now, and we'll get that 1 plus 2r, and r is 3 over x according to equation number 2, equals to x squared. So in total we got that 1 plus 2 times 3 over x equals to x squared. 2 times 3 is 6, so we write it down that according to equation number 1, 1 plus 6 over x equals to x squared. So we got that 1 plus 6 over x equals to x squared. Here we'll multiply equation number 1, this equation, by x. I've already explained that it is allowable to multiply the equation, any equation, by x, because x can never be 0. X is the side of a triangle, it can never be 0, it must be a positive number, therefore it is allowable to multiply equation number 1 by x. Okay, so we'll get that x plus 6 equals to x cubed. Here we will subtract x from equation number 1, and we will get that x cubed minus x equals to 6. We will subtract 6 from equation number 1, and we will get that x cubed minus x minus 6 equals to 0. As you can see, x equals to 2 is a solution for equation number 1, because x cubed, if x equals to 2, then x cubed will be equal to 2 cubed. 2 cubed is 8, and 8 minus 2 is 6, and 6 minus 6 is 0. So x equals to 2 is a solution to equation number 1. So here we will subtract 2x squared from equation number 1, and then we will add to equation number 1 2x squared. So minus 2x squared plus 2x squared is 0, so we actually change nothing because we add 0 to equation number 1. Therefore it is allowable to do this operation. So we subtract 2x squared from equation number 1. X cubed minus 2x squared plus 2x squared again, minus 2x squared plus 2x squared is 0, so it is allowable to do this operation because we change nothing. We add 0 to equation number 1. So x cubed minus 2x squared plus 2x squared minus x minus 6 equals to 0. And minus x equals to minus 4x plus 3x. Again, minus x equals to minus 4x plus 3x. So we will substitute minus x in equation number 1 by minus 4x plus 3x, and we will get that x cubed minus 2x squared plus 2x squared, and instead of minus x we write down minus 4x plus 3x minus 6 equals to 0. So we got this equation number 1, and okay, here we will take a common factor of x squared out of these two expressions, and we will get that x squared is a common factor, and inside the bracket we will have from this expression x, and from this expression, if we took x squared as a common factor, we will receive minus 2. And here we take a common factor of 2x out of these two expressions. 2x is a common factor of these two expressions, and if 2x is a common factor, then what is left from this expression? If we took 2x as a common factor of this expression, what is left is it is actually x, and what is left from this expression after we took 2x as a common factor, what is left, it is actually minus 2, and we will take a common factor of 3 out of these two expressions. So what is left from 3x is 3 is a common factor. What is left from 3x is x, and what is left from minus 6 after we took 3 as a common factor, what is left, it is actually minus 2, all equals to 0. So we got this equation number 1. So here we will take a common factor of x minus 2 out of these expressions, and we will get that so x minus 2 is a common factor out of for these expressions, and inside the brackets we will have from this expression what is left after we took x minus 2 as a common factor. What is left, it is actually x squared, and what is left from this expression after we took a common factor x minus 2 as a common factor, what is left, it is actually 2x, and what is left from this expression after we took x minus 2 as a common factor, what is left, it is actually 3, and all equals to 0. So here we have two solutions possible from this equation number 1. The first solution that is possible, that is x minus 2, either x minus 2 equals to 0. If x minus 2 equals to 0, then we get that 0 equals to 0. And the second possibility is that this expression equals to 0, or the quadratic equation x squared plus 2x plus 3 equals to 0. So we have the quadratic equation that states that x squared plus 2x plus 3 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This is general quadratic equation, the general formula for a quadratic equation. When a, b, and c are the coefficients, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. X actually equals to minus b plus minus root of b squared minus 4 times a times c over 2a. Okay, again here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. So if we relate to our specific quadratic equation, so in this quadratic equation a equals to 1, b equals to 2, and c equals to 3. So we will put the data inside this equation in order to find out the value of x. And we will get that x equals to minus b equals to 2, therefore minus b will be equal to minus 2, plus minus root of b squared. B is 2, so b squared is 2 squared. 2 squared is 4. Minus 4 times a is 1. So minus 4 times 1 is minus 4 times c is 3, so it is minus 4 times 3 over 2 times a is 1, so 2 times 1 is 2. So in total we got that x equals to minus 2 plus minus 4 times 3 is 12, so, and 4 minus 12 is minus 8 over 2. So in total we got that x equals to 2 plus minus the square root of minus 8 over 2. As you already know, a negative number doesn't have a root. So therefore it is not possible, or this is not a correct solution, because the square root of minus 8 is not a real number, and we know that x is a side of a triangle, and a side of a triangle must be a positive number. Therefore, x cannot be equal to something that is not a real number. Therefore, the possibility that x squared plus 2x plus 3 equals to 0 is not correct, and we left only with the solution that the first solution that x minus 2 equals to 0. If x minus 2 equals to 0, then x equals to 2, and we have already found out that, according to equation number 2, that r times x equals to 3. R times x equals to 3, and we know that x equals to 2, so we can substitute x in equation number 2 by 2, and we will get that 2 times r equals to 3. Here we divide equation number 2 by 2, and we will get that r equals to 3 over 2 units, or r equals to 1.5 units. Okay, so we actually found out that the radius of this semicircle equals to either 3 over 2 units, or it equals to 1.5 units. Okay, so that is the answer to the question. Now I'll summarize the lecture. Actually, we wanted to find out the radius of this semicircle. We have here right triangle. Triangle ABC is a right triangle because angle ABC equals to 90 degrees. We know that side AB equals to 3 units. Line segment DC equals to 1 unit. And we want to find out the radius of this semicircle that is actually inscribed by triangle, the right triangle, triangle ABC. Actually, in order to find out the radius of this semicircle, we must use 3 new rules. I actually presented to you 3 new rules, and we implemented those 3 new rules in our drawing in order to find out the radius of this semicircle. And rule number 1 is actually 2 tangents theorem, and the 2 tangents theorem states that the length of 2 tangents from an external from a common external point for a circle are equal So I will repeat again on rule number 2, on rule number 1. According to rule number 1, the lengths of 2 tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this circle and we have point P that is an external point in relation to this black circle. Why point P is the external point? Because it is not located inside the black circle nor on the black circle, therefore it is defined as external point to this circle. And if from point P we draw two tangents to this black circle, then the lengths of those two tangents will be equal to each other. That is to say, the length of the first tangent is PA and the length of the second tangent is PB. And according to rule number 1, whenever you draw two tangents to a circle from an external point to this circle, then the length of those two tangents will be equal to each other. That is to say, PA equals to PB. Okay? So this is rule number 1, and we actually implemented rule number 1 in our drawing, because in our drawing we have point A that is an external point to this semicircle, and from point A we have two tangents to this semicircle. The first tangent is tangent AB, the second tangent is tangent AE, and according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AB equals to AE. Again, AB equals to AE according to rule number 1. AB equals to AE, but we know that AB equals to 3 units. It is given us in the question that AB equals to 3 units. So from this equality we can derive that AE also equals to 3 units. Okay, so we can write here that AE equals to 3 units. Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its points of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and tangent AB, actually tangent AB is tangent to the black circle as point M, or point M is the point of tangency, and we have radius OM. The radius OM is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency. Then if this is the situation, then the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So whenever you have a radius that is drawn to the point of tangency, like in this drawing, this radius is drawn to the point of tangency, that is to say, it is drawn to point M, then the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so we can actually also implement rule number 2 in our drawing, because we have here tangent AC is tangent to the semicircle at point E. That is to say, point E is the point of tangency of tangent AC with the semicircle, and we have radius OE that is drawn to the point of tangency. That is to say, it is drawn to point E, that is the point of tangency. Therefore, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So, actually, because of the fact that angle OEC equals to 90 degrees, according to rule number 2, then the green triangle is a right triangle. And we have the Pythagoras theorem. In any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the hypotenuse in the green triangle is OC. and the two perpendiculars are OE and EC. So according to the Pythagoras theorem, the square of the hypotenuse, that is OC square, equals to the sum of the squares of the perpendiculars equals to OE square plus EC square. But OC, side OC of the green triangle equals to R plus 1. So OC square is R plus 1 square. OE equals to R. Therefore, OE square is R square, and EC equals to X according to our definition. Therefore, EC square will be equal to X square. So in total, we got that R plus 1 square equals to R square plus X square. We open the brackets in this side of equation number 1, and we got that R plus 1 square equals to R square plus 1 plus 2R. And it equals to R square plus X square. Here we subtracted R square from equation number 1, and we got that 1 plus 2R equals to X square. So according to equation number 1, 1 plus 2R equals to X square. Then we focus on the right big triangle, triangle ABC, and we also focus on the green right triangle, triangle OEC. On those two triangles, we have those two angles that are equal to each other. They are both right angles. So angle ABC of triangle ABC equals to angle OEC of triangle OEC. We also have this angle. It is a common angle. It belongs to both triangles. Angle C belongs to triangle ABC, and angle C also belongs to triangle OEC. Therefore, we can write down that angle C equals to angle C. It's a common angle, and we also proved that those two angles are equal to each other. Those two angles are equal to each other according to third angle theorem. Okay, so angle BAC equals to angle EOC according to third angle theorem. What is third angle theorem? The third angle theorem states that if two angles of one triangle are equal to two angles of another triangle, then the third pair of angles must be also equal. Okay, I repeat again. If two angles of one triangle are equal to two angles of another triangle, then the third pair of angles must be equal. So what is the meaning of third angle theorem? The meaning of third angle theorem is that if we have triangle ABC, this triangle, with angles alpha, beta, and gamma, and we have also triangle CDE with angles alpha, beta, and theta, then the third pair of angles, that is to say, are equal to each other. The third pair of angles are equal to each other, that is to say, angle gamma equals to angle theta. We proved that those two angles are equal to each other. Why? Because we know that the sum of the angles in any triangle is 180 degrees, therefore alpha plus beta plus gamma equals to 180 degrees in triangle ABC, and in triangle CDE also the sum of the angles are equal to 180 degrees, that is to say alpha plus beta plus theta also equals to 180 degrees. Then we subtracted alpha from equation number 1, and we got that beta plus gamma equals to 180 degrees minus alpha. Then we subtracted beta from equation number 1, and we got that gamma equals to 180 degrees minus alpha minus beta. Then we subtracted alpha from equation number 2, and we got that theta plus beta equals to 180 degrees minus alpha. Then we subtracted from equation number 2 beta, and we got that angle theta equals to 180 degrees minus alpha minus beta. So actually angle gamma equals to 180 degrees minus alpha minus beta, and the angle theta also equals to 180 degrees minus alpha minus beta. So therefore we found out that both angle gamma equals to 180 degrees minus alpha minus beta, and again zeta also equals to 180 degrees minus alpha minus beta. From this equality we can derive that angle gamma equals to angle theta. In this way we actually proved that the third angle theorem is true. And we proved that if we have two triangles with two angles that are equal to each other, like in this drawing, angle alpha and beta are equal in both those two triangles, then the third pair of angles will be also equal to each other. That is to say angle gamma equals to angle theta. So we actually proved that all three angles of triangle ABC are equal to all three angles of triangle OEC. Therefore, we proved that triangle ABC is similar to triangle OEC according to angle similarity rule. Okay? We proved that triangle ABC is similar to triangle OEC according to angle similarity rule. And from the fact that triangle ABC is similar to triangle OEC, we can derive that AB over AC equals to OE over OC. AB equals to 3 units, AC equals to 3 over X, AC equals to 3 plus X, AB equals to 3 units, AC equals to 3 plus X, OE equals to R, and OC equals to R plus 1. So we got this equality. We cross multiplied equation number 2, and we got that 3 times R plus 1 equals to R times 3 plus X. We open the brackets in equation number 2, and we got that 3R plus 3 equals to 3R plus X. Here we subtracted 3R from equation number 2, and we got that 3 equals to R times X. We divided equation number 2 by X, and we got that the radius of the semicircle equals to 3 over X. According to equation number 2, but we have already found out that according to equation number 1, 1 plus 2r equals to x squared. So we can substitute r in equation number 1 in this equation by 3 over x, because r equals to 3 over x. So we substituted r in equation number 1 by 3 over x, and we got that 1 plus 2 times 3 over x equals to x squared. 2 times 3 is 6, so we got that equation number 1, that 1 plus 6 over x equals to x squared. We multiplied equation number 1 by x, and we got that x plus 6 equals to x cubed. We subtracted x from equation number 1, and we got that x cubed minus x equals to 6. Then we subtracted 6 from equation number 1, and we got that x cubed minus x minus 6 equals to 0. Then we added to equation number 1 2x squared, and when we subtracted 2x squared, so we changed nothing, because minus 2x squared plus 2x squared is 0. So it is allowable to do this operation, and we got this expression. Then we know that x equals, we know that minus x equals to minus 4x plus 3x. So we substituted x in equation number 1 by minus 4x plus 3x, and we got this equation number 1. Then we took a common factor of x squared from those two expressions, and we got that x squared, inside the brackets we have x minus 2, and we also took a common factor of 2x out of this expression, and inside the brackets what is left is x minus 2, and we also took a common factor of 3 out of these two expressions, and inside the brackets we have x minus 2. So here we took a common factor of x minus 2 out of equation number 1, and we got the expression that x minus 2 times x squared plus 2x plus 3 equals to 0. So here we have two solutions that are possible. The first solution, that either x minus 2 x minus 2 equals to 0, or then we'll get that 0 equals to 0, or the other possibility is that x squared plus 2x plus 3 equals to 0. That is the second solution. So we have the quadratic equation that states that x squared plus 2x plus 3 equals to 0. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of the general quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula, according to this formula. And here also a, b, and c are the coefficients of this quadratic equation. So we solved our specific quadratic equation. We found the value of x according to this special formula for x. We know that in our specific quadratic equation a equals to 1, b equals to 2, and c equals to 3. So all what is left here is to put the data inside this equation to find out the value of x. And we found out that x equals to minus b, b is 2, so minus b is minus 2, plus minus root of b squared, b is 2, so b squared is 4, minus 4 times ac, 4 times ac is 4 times 1 times 3, or 4 times 3 is 12, over 2a, 2a is 1, so 2a is 2 times 1 is 2. So in total we got that x equals to minus 2 plus minus, and 4 minus 12 is minus 8. And there is no root for a negative number, and because of the fact that there is no root for a negative number, there is no root for minus 8, therefore there is no solution to the quadratic equation of x squared plus 2x plus 3 equals to 0. Therefore, the possibility that the solution of x squared plus 2x plus 3 equals to 0 is not correct possibility, and we left only with the solution that x minus 2 equals to 0. If x minus 2 equals to 0, then x equals to 2. X equals to 2, so, and we already found out in equation number 2 that r times x equals to 3, so we can substitute x in this equation number 2 by 2. So we substituted x by 2 in this equation, and we got that 2r equals to 3. We divided equation number 2 by 2, and we got that the radius of the semicircle equals to either 3, the radius of the semicircle equals to either 3 over 2 units, or it equals to 1.5 units. I'll repeat again, the radius of this semicircle equals to either 3 over 2 units, or it equals to 1.5 units. Okay, thank you very much.